All right, so for this video, I'm going to show you how we go from just the simulated example of what it could look like to what hopefully will be a reality. So we have here a piece of wood that we were kind of just prototyping with and estimating this is what we're going to build. Now we need to secure this wood so that this machine doesn't move it around as it's cutting. Now I noticed that I have a good amount of space here, that I think I'm just going to screw it to this waste board so that it's not moving anywhere and I can cut out my design right here. So I grabbed some screws. We're going to start with, also that was the other thing I set up, was we're going to start with the V-carve bit. So here, if it focuses, is the V-carve bit. That's what it looks like if it shows. So anyway, it's a V-carve bit, and then we'll finish with our end mill that is just going to cut the thing out. And I think I talked about using the square edge end mill. I think we'll just use a round edge end mill just for convenience of cutting this thing out quick and not wasting the resources on something unnecessary. Anyway, so I also arranged these. I think that's where that 15-minute video cut off before was. The first thing was the V-carve, second thing is the pocket, and third thing is the contour. And I'll hide the simulation so it'll highlight V-carve first, V-carve, then pocket, then outer cut. And the outer cut still has tabs, so it should be held in pretty good, but still is just best this way. All right, so from this software, we save it, and I'm just going to call it Hurst Test. And then that creates an NC file. Then we go to Carbide Motion, which is only on this computer. So Carbide Create is on all your guys' computers. But Carbide Motion is only on the one computer that operates the machine. So we're going to actually secure this first. So let's do that really quick. I don't know how that camera's gonna look there. So I want a pilot hole so it doesn't split my wood. Secure it in there. Don't need it super strong, just enough that it's not going anywhere. Notice I'm using a small amount of trigger speed, so it just gets lots of nice torque. And then I want that tip to show me where that material is. So where is the bottom left corner is what it's looking for orientation of. So this red dot right there is the start of the tool. So if I know that this is 4 inches and I know that this is actually 3.5 inches, so actually I kind of need to maybe move that because it's going to be a little bit closer up on here. It's going to be 1/2 inch. So it's not going to be directly in the center. It's going to be 1/2 inch up from the center. So just have to keep that in mind. So I suppose I could make a quick adjustment to make sure that I know exactly where this is going to be. So if I go back to setup, 3.5, 3.5, and just right in the middle of it, toolpath, save. First test 2, go back to motion. All right, so now we're gonna Z this machine. So we need to move that tooltip into that same corner as the software thinks it is in. And there we go. And so you can click your increments so that instead of doing large motions, it just does little baby motions. So I can get it exactly where I want it. Okay. Now, I'm also looking at this is curved. It's bowing up a little bit. So if I set it right down on the bottom corner there, it's going to dig in deeper in the middle part. So I'm just going to give it a small amount offset. All right. So now I set the 0. So that's where my new home 0 location is at. Then I need to run the file that I just made. First test. So we're actually pretty ready to hit start. So we're gonna hit start. Then this machine doesn't automatically turn on. It's fairly noisy. It has the ability to go faster if you're impatient, like myself. Does its thing. Takes a little while, but looks like I All right, so now it wants me to do a tool change. So next is to insert in the end mill. I think we're gonna use this one just for the sake of, I don't know. Just gonna cut this thing out 3 times, or 3 passes of it. So looking at my design, it cut in too deep for the, this tooltip needs to go down just less material for it to be legible. It went in too deep, but whatever. It's a first attempt in learning, and that's kind of the whole idea that I'm trying to show you is rapid prototyping. So we'll definitely try less depth. Also, when I set that offset here, I was floating in air because I kind of was like estimating how much I can see it arcing up. Anyway, it's not a flat material. So, you know, there's art, there's science somewhere in the middle that we're trying to get this thing to work. So let's put this down, change our tooltip out. Changing our tooltip out. Apparently I dropped that. So to change the tooltip out, there's a little button in here. You push it, and then you can unscrew this. So it comes out. This is called a collet. So here's the tooltip that we had. Here's the tooltip we want. So we're going to stick this inside the collet, stick it back in there. And now the machine currently does not know where the end of this tool is because we had a different bit in there. And there's no way for me to know exactly how far that bit is from the spindle end to the tip of the tool. So, because each operator puts it in differently. So what I now need to do is set a new Z to what that is. So I'm going to go back to I think this is where I ran into problems when I was doing multiple jobs, is it's gonna just keep going with the same Z without knowing what the new Z is. So if I hit resume, that's not gonna work, right? Yep, it's just gonna go down and do its thing. So we're actually gonna have to stop this job, go back to the file, disable this one, save the G code again, we'll do test 3. I'm gonna have to think of how we do multiple tool tips for teaching you guys how to do that. I think, yeah, just multiple jobs is the way that I've always done it. So we're gonna load 3, and then we're gonna jog to current position. And now we just need it to come down to what we are specifying as Z. So we're gonna go down. Pretty good. Set 0, 0 done. Then go back to run and start. Turn this back on. finish with that cut job. And let's review what we got. So hey, that looks pretty close to what our prototype simulated was gonna look like. Minus, clean this place up. Okay, minus going down too deep. I also, okay, so I thought I made the tabs going two passes, one tab, but anyway, the inverse of that, it's fine. So now let's take this off, cut it up, and see how it goes. I think when I teach you guys and have you guys do this, I'll find a better way to secure materials to the table so they're not moving. And so it's easier to move around between there. All right, so I'm gonna cut this out. Alright, so we have a little chunk that says Mr. Hurst on there. Needs a little bit of sanding. I think when I chose to do the round bit versus the square end mill, then you can kind of see that kind of rounded edge. My measurements were pretty close with 0.6 of the depth of this thing for 3 passes. So did a good job there. And yeah, let's just go back and compare with the original design. If I can operate this with my left hand. It's a little harder than I thought. Use a computer mouse. Alright, so that's what we had simulated. This is what we got. Bada bing, bada boom. Not too far off. A little bit of work to get the second version a little bit better and call it good.